Hey everyone, so this video follows on from the binary classification with TensorFlow, but in this case we're going to be classifying our data into multiple different categories. So a good example of this might be recognizing different animals in an image, so cats, dogs, horses, cows, sheep. So in this notebook we'll be doing a fairly simple problem. So jumping into the code, the first thing we have is the standard set of imports, and then we have some constants for use later. So we have our image width, our image height, and our training batch size. So we're going to generate some dummy training center. So we'll have 4 different labels. So we'll have a blank, a square, a circle, and a triangle. So I've created an infinite data generator, and we're going to use one-hot encoding for the value of our labels. And to do this, we use the tf one-hot function. So for the labels we have above, this will generate blank with a 1, 0, 0, 0, square 0, 1, 0, 0, circle 0, 0, 1, 0, and triangle 0, 0, 0, 1. So here's our slightly more complicated data generator. So we now have 4 different classes, and we have our image. So if y is 1, we generate a square image. If y is 2, we generate a circle. And if y is 3, we generate a triangle. And if y is 0, then we just do a blank image. And then we yield our image, and we yield a one-hot encoded version of y. So from our generator, once again, we can create a data set. So we have our output types for our image and our label. We have the output shapes, so one for our image, and now our label has 4 values. So we can visualize our training set. So let's plot the images that come out, and you can see that we have a blank, we have a square, we have a circle, a triangle, followed by a blank, square, circle, triangle. So our data set just generates a sequence of random images containing blank, square, circle, or triangle. Now obviously this is still a very simple problem, so our model doesn't have to be that sophisticated. We have a convolutional layer, we have a max pooling layer, we flatten that, feed it into a dense layer, and then we have our output layer. So things to note, our output layer now has 4 neurons, and the activation function is softmax. So what softmax does is it takes the output from these 4 neurons and makes sure they sum up to the value of 1. So let's compile our model, and now the important thing to note here is that we use the categorical crossentropy loss function. So let's compile our model, and now we can fit our model to our data set. So obviously we have a slightly more complex data set, so this will take slightly longer to train. So I've trained my model for 10 epochs, and we're getting almost 100% accuracy. So let's generate some more samples and see what the model predicts for them. So you can see our model's actually predicted very well. So it's found a blank image, an image with a square, an image with a circle, image with a triangle. It's not got anything wrong. So some interesting things to see here. We can work out the max indices from the prediction using tf argmax. So then when we plot our images, we can work out which category it was most confident the image was. And if we print out the values from our model, you can see that mostly it's getting a 1 or a 0 for the categorization. You can see on this particular sample, it was slightly confused between the circle and the square. So it was 99% sure it was a circle and 1% sure it was a square. but mostly our models correctly identified the different shapes. So hopefully, if you were following along, you got similar results. You can try shrinking the size of the model until it starts failing. Try feeding a completely different shape into the model. And maybe you could try modifying the code to use the sparse categorical cross-entropy loss function. So this can make things simpler in some cases because you don't need to one-hot encode your label. The sample code in the GitHub repo along with this workbook and the previous binary classification workbook. So feel free to clone that and play around. I hope you found this video interesting, and if you did, please hit the subscribe button. There'll be more videos coming, and we'll be using some of this TensorFlow work in an exciting hardware project quite soon.